Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. In each Hain step, the nitrogen is first fully methylated to a quaternary ammonium salt, then undergoes E2 elimination preferentially at the least hindered beta carbon, Hofmann's rule, opening the ring. Case, D-piperidine, unsubstituted, Step 1 Hain, piperidine N, N-trimethylpiperidinium iodide elimination gives spent 4N1 vial dimethylamine, 5N, N-dimethylaminopent 1 Na, i.e. CH2 is equal to CH, CH2, 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 NMe2. Actually the ring opens to give N-dimethylpent 4N1 amine, CH2 is equal to CH, CH2, 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 NMe2. Step 2 Hain, the open chain amine is methylated again to quaternary salt, then elimination gives penta 1,4-diene, CH2 is equal to CH, CH2, CH2, CH is equal to CH2. Wait, that is hexa 1,5-diene, H to C is equal to CH, CH2, CH2, CH is equal to CH2, product Q. But let me reconsider. Piperidine ring has 5 carbons plus 1 N. Ring opening gives a 5-carbon chain with terminal alkene and dimethylamino group at the other end. Ring opening of piperidine by Hain, N is between C2 and C6. Elimination occurs at the less hindered end, giving CH2 is equal to CH, CH2, 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 NMe2 is equal to 5-dimethylamino, pent 1 Na. Second Hain on this, methylate N to give CH2 is equal to CH, CH to CH to CH to NMe3, plus elimination gives CH2 is equal to CH, CH2, CH2, CH is equal to CH2 is equal to hexa 1,5-diene is equal to product Q. No, that is 6 carbons, but piperidine only has 5 carbons in the ring. Piperidine has 5 CH2 groups plus N. After ring opening, N-dimethylpent 4N1 amine is equal to Me2N, CH to CH to CH to CH is equal to CH2. Second Hain, Me3N, CH to CH to CH to CH is equal to CH2, plus eliminate to give CH2 is equal to CH, CH2, CH2, CH is equal to CH2 is equal to penta 1,4-diene. The chain is 5 carbons, H to C is equal to CH, CH2, CH is equal to CH2 is equal to penta 1,4-diene is equal to product P. So, D, T. This matches the given answer. Case A4-methylpiperidine The methyl is at C4, para 2N. Ring opening by first Hain, elimination, at less hindered beta carbon gives an open chain amine. The ring has C4 bearing a methyl. After 2 Hain steps, the product should be a diene with a methyl branch at the middle. The product assigned is SH to C is equal to CH, CH3, CH is equal to CH2 is equal to 3-methylpenta 1,4-diene. First Hain on 4-methylpiperidine opens ring to give N-dimethyl 4-methylpent 4N1 amine or similar. The methyl at C4 means elimination gives a branched intermediate. After 2 full Hain cycles, we get H to C is equal to CH, CH3, CH is equal to CH2 is equal to S. So, A, S. Matches. Case, B3-methylpiperidine Methyl at C3. After 2 Hain steps, Hofmann elimination, least substituted alkene preference, yields a product where the methyl ends up on the carbon bearing a double bond as a substituent on a non-terminal carbon. The product is RH to C is equal to CH, CH2, C, CH3 is equal to CH2 is equal to 2-methylpenta 1,4 diene. So, B, R. Matches. Case, C2-methylpiperidine dash. Methyl at C2, alpha 2N. After 2 heme steps, the product is the longer diene, QH to C is equal to CH, CH2, CH2, CH is equal to CH2 is equal to hexa 1,5 diene. Wait, but piperidine only gives penta 1,4 diene. With a methyl at C2 after ring opening we get a 6-carbon chain, 5 ring carbons plus 1 methyl is equal to 6 carbons total, giving hexa 1,5 diene is equal to H to C is equal to CH, CH2, CH2, CH is equal to CH2 is equal to product, Q. So, C, Q. Matches. Summary. A. 4-methylpiperidine double heme S, H to C is equal to CH, CH3, CH is equal to CH2. B. 3-methylpiperidine double heme R, H to C is equal to CH, CH2, C, CH3 is equal to CH2. C. 2-methylpiperidine double heme Q, H to C is equal to CH, CH2, CH2, CH is equal to CH2. D. Piperidine double heme P, H to C is equal to CH, CH2, CH is equal to CH2. Therefore, the correct answer is A, S, B, R, C, Q, D, P. Therefore, the correct matching is A matches S, B matches R, C matches Q, D matches P.